Hello and welcome. Have you ever wondered how scientists can identify a chemical just by shining light through it? Or how they determine the color of a substance at a molecular level? The answer lies in a powerful technique called electronic spectroscopy. Today, we're going to break down the fundamental principle behind it. At its heart, electronic spectroscopy is all about the interaction between light and electrons in atoms or molecules. Imagine electrons orbiting a nucleus. They don't just wander around randomly, they exist in specific energy levels, or orbitals. You can think of these levels like the rungs of a ladder. An electron can be on one rung or another, but never in between. The lowest energy level, the most stable place for an electron, is called the ground state. Now, here's where the light comes in. When we shine light, which is a form of energy, onto a sample, the electrons can absorb that energy. However, they are very picky. An electron will only absorb a photon of light if that photon has the exact amount of energy needed to jump from its ground state to a higher, empty energy level, known as an excited state. It's like needing the perfect amount of energy to leap from the first rung of the ladder to the third, not a little more or a little less. This all-or-nothing energy absorption is a core concept called quantization. The type of light used in electronic spectroscopy is typically in the ultraviolet, UV, or visible range. So, what does a spectrometer do? It shines a whole range of UV and visible light wavelengths through a substance and measures which specific wavelengths get absorbed by the sample. The result is a graph called an absorption spectrum. This spectrum shows peaks at the wavelengths where light was absorbed, which directly correspond to the specific energy jumps the electrons made. Each molecule has a unique set of possible energy jumps, so its absorption spectrum acts like a unique molecular fingerprint. By analyzing this fingerprint, scientists can identify the molecule and even figure out its concentration. So, to summarize the principle in a few steps, first, light is passed through a sample. Second, electrons in the sample absorb photons of very specific energies. Third, this absorption causes the electrons to jump from a low-energy ground state to a high-energy excited state. Finally, the spectrometer records which energies or wavelengths of light were absorbed, creating a unique spectrum. It's a beautifully simple yet powerful principle that opens a window into the hidden world of molecules. Thanks so much for watching. If you found this explanation helpful and want to learn more about the fascinating world of chemistry, please consider liking this video and subscribing to the channel. Your support helps us create more educational content just like this. See you in the next one.